Hey, so I wanted to do a video. I actually have to, I'm finishing my first call. I gotta run home real quick. And I was thinking of my water experiment while I was cleaning this oil system. And I'll be 100% honest, I think I'm really on to something that people at NASA are also working on. And I'm not trying to pat myself on the back. I'm just saying it's worth pursuing from a experimental perspective based on what I'm both reading and experiencing. So I don't have objective test equipment yet to measure the differences, but I'm experiencing a difference, and from everything I'm reading in kind of logical analysis, I'm on the right track. Now, what I don't know and what I should know is exactly what the voltage is I'm generating in the water. Now, the reason I should know that is because it takes a certain amount of voltage to dissociate oxygen and hydrogen from H2O. Now, if we are in fact causing electrolysis because of catalysts in the water passing by static magnetic fields, then that's cool and a bit of dumb luck, because I have no control over what's in the water, and I don't know if my magnet strength is high enough anyway. But where I do see kind of intrinsic limitations on my design, irregardless of those unknowns, is on the flow rate or the velocity of the water, but more specifically the flow rate in the persistence of the exposure to the magnetic fields, if you know what I'm saying. So let's say if I'm generating 1 part per trillion O4 molecules every time I pass the magnets at 1 foot per second. I'm guessing, but whatever. Let's say the water's moving at 1 foot per second. My magnet strength is X, and I'm generating 1 part per trillion O4 molecules, stable liquid oxygen, right? Well, I'm only running the water for a short period of time, and in that time, it's getting into the piping system, but it's a very small amount because the magnetic exposure for that fixed amount of water is very small. Now, I could try to add more and more magnetic ionizers, but without knowing if I have the right magnetic field strength, it strikes me as pretty expensive. And if each one I pass is only adding 1 part per trillion with probably diminishing returns, especially once I pass the filter, then I see some design problems, basically. And where the solution lies is, instead of adding more and more magnetic ionizers, to add a recirc pump to my cold water line before my water filter. So I'm essentially running an ECM bronze pump in a loop and exposing that loop to a very powerful magnetic field before I filter it. And if I were to do that, then each pass of the water in the loop, which would be running all day or 2 hours on whatever I program it to do, each pass of the loop is generating 1 part per trillion with diminishing returns. But then when I get home from work, that loop could be saturated with 30% O4 molecules. If you get what I'm saying, it might be very well worth it to install my own pump and exponentially increase the exposure based on time. It would be taking it from like a kid level to actual like manufacturing on a chemical level, to be involved in chemical manufacturing. Seriously. So that's the next step up in my mind, is identifying the correct strength of the magnets. And then unfortunately, I don't think I have a bronze pump. So I've run into them time from time when we do like hot water heater change outs and the people don't use their recirc line or whatever. They're expensive pumps. You can spend like anywhere from $200 to $500 on a high velocity pump that is lead free and bronze. So I don't have one right now. And I also would like to get an ECM one if I'm going to do this. But that's where I'm at. I think it's very real, and I think it is very, very medicinal. I just don't think I have the right concentration yet.